Right, so in this video, we're going to be dealing with compound inequalities. So I'm going to be honest with you, I was confused with compound inequalities when I first learned it. This was a concept that I really struggled with, but over time I kind of got it because compound inequalities aren't too bad. You just need to understand what they are, and then you'll be able to solve them quite easily. So compound inequalities are basically multiple inequalities that are sort of combined together using the word and or the word or. The word and is basically referring to the inequalities that overlap each other, and or is the union of the inequalities, basically inequalities that are put together even though they have separate domains or separate, I guess you could say domains or separate values that they cover. I'll show you some examples. So let me write this here. Compound inequalities. And we have two sort of options here when we think about compound inequalities. You have the and keyword and the or keyword. Okay, so let's try to understand these here. So let's look at the and first. So a simple compound inequality that deals with the and can be x is greater than 5 and x is less than 7. Now this is something that kind of makes sense, right? Say x is say the number of people that can attend a party that you're holding at your house. Your house is relatively small, so you can't hold a lot of people, but you can hold up to like 5 people, right? So this inequality here, this compound inequality, says that the number of people that you can hold, it has to be greater than 5, but it has to be less than 7. So you have to have the number of people between 5 and 7. Of course, here it would include the decimal points. You can't have like 5.1 people, but that's just not a good example, I guess. But that's just something to hopefully help you understand what the and inequality is, and compound inequality. So how would you graph this here? And what's the alternate way of writing this? The alternate way of writing this without this keyword and here would be just, you've probably seen this kind of a form before. So x is supposed to be greater than 5, but less than 7. So this is a way that you can write it. Or if you wanted to put the 7 in front, right, you want to put the bigger number first, you could do that too. So x is less than 7, but greater than 5. Both of these are valid. You could write it either way. All three of these are the same thing. They say the same thing. Okay? And that's the end. The end is actually relatively easy. Both of them are not too difficult once you understand them. So let me see. Let me try to graph this here. Try to draw a straight line, best of my abilities. So we don't really need the negatives, but I'll just include the -1 just for fun. 0 and then 1, 2, 3, 4, 5, 6. This is all we need really, but I'll just include one more, like 8. Whoops. That's not what I wanted. Let me get this out and extend this a little bit. All right, that's good. 8, 9. So if this is x, right? The values for x, potential values, x can be. So if we look at this one, let's look at this one. So let's first graph x is greater than 5. X is greater than 5 would, let me do this in a different color. Let me do this in green. So x is greater than 5. Well, let's look at that one first. So we've graphed these inequalities before. It's quite easy. It's an open circle. It's supposed to be greater than 5. And this is what it says. Then the second one is saying x is less than 7. So let me do this one in white. So x is less than 7. So this is 7. X is less than it, so it's an open circle here, and then it's less than it. So it's going to go all the way to the end. There you go. So yeah, as you can see, there's an overlapping area that's right over here, right? This overlapping area. And this overlapping area is actually the area we're focusing on. So this overlapping area that you see over here, this overlapping area, This overlapping area is what this compound inequality is referring to. So if you wanted to graph it, you wouldn't graph all of this. You don't need all of this side here and this side here. You don't need it. Only thing that you would graph is this portion right over here in between, because that is the portion that this compound inequality is referring to. For example, remember when you had x is greater than 7? So when we had x is greater than 7, we had this graph, and then say this is 5, this is 7. We only looked at this portion right over here. But except when we have a compound inequality, when we have and, we're looking at a portion, we're looking at this portion over here, this portion here. And that would be the range of what you're looking at. That would be from this point to this point, not including the endpoints. That's what you would graph, because that is what this compound inequality covers. Okay, so that's that. That's graphing these compound inequalities, and this is what you're looking at. So this is hopefully helpful with the and. Now let's look at the or. The or is basically talking about the union of two separate inequalities, and they cover separate areas. They're not going to be overlapping like the and was. So say if we have something like x is greater than 5 or x is less than 3. Obviously, x is greater than 5, x is less than 3. They're separate portions, right? Like 5, so say if we had a number line, this would be 3 and this would be 5. Greater than 5 is this side, less than 3 is this side. There's this area that we're not covering because we don't care about it. That cannot be a part of this of the portion that this covered, but it can be anything in this side, it can be anything in this side as well. That's the or, right? And in the or, if giving you an example of this, is basically something like, say your parents say that, well, again, I can't keep the same example again, but let's say that you have a decision to make in life, and there was, in this decision, you could either have x being or x referring to some value. You can have that value being greater than 5, or it has to be less than 3, cannot be in between. Then this compound inequality would essentially cover that situation. So hopefully that made sense. That's not a very good example, but for the or inequality, the compound inequality, this is really the only way that you can cover it. This is the only way, because the or inequality is two separate inequalities that are combined together to form a certain inequality. And really, I think these compound inequalities kind of confuse me because I didn't understand them in terms of examples. But when you think about it in terms of an example, and you think about it in terms of, something that's going on, and why you would use this compound inequality, then it kind of makes sense. So let's see the graph of this one. So let's graph this. We don't really need the negatives again, but we'll just include a little bit of it. All right, so this is enough. So x is supposed to be greater than 5, so let me do this in different colors. X is greater than 5, so 5 is here, open circle, to this direction. We've done this before, so yeah, this shouldn't be hard. I even made a separate video on this, so you can go check that out. X is supposed to be less than 3, so open circle here, and less than 3. Not very difficult, hopefully, right? This is it. This is all you need to care about. These two portions are what are covered by this compound inequality. And again, compound inequalities, coming back to this idea, basically what you're talking about with a compound inequality is you're basically talking about including a certain portion of something on a number line, and this could be very useful in many different situations in the real world. So whenever you think you're confused with what a compound inequality is, what is this and, what is this or, you're going to see this in programming as well if you ever do programming in your life, which you should. It's very fun. But anyway, a compound inequality is basically, think about it in terms of the real life, in terms of if you have a certain number of something, and there's a restriction on the domain, on the restriction on what you can have, you can potentially have an and or an or situation in where you have a compound inequality for the values that are potentially included in that situation for that quantity. So it's really interesting thinking about compound inequalities, and they, I think they're harder, they look harder than they really are. So I hope you found this video helpful.